Good morning, everyone. Thank you for joining the Smart Technology Time is Money webinar. My name is Blaine Mead, and I'm the CEO of MiSTAR Gaging Tool Company. We're a leading gauging, inspection equipment, and specialty tooling distributor. Our company is offering these virtual seminars opportunities as an innovative extension of our solutions-based business model. We encourage you to engage with us throughout the webinar. If you have any questions, please type into the chat, and our speakers will answer during the Q&A at the end. This webinar will teach you about breakthrough technologies and how to utilize these solutions to improve your bottom line. I want to thank NuScale Robotics, Marposs, Mitutoyo, Renishaw, and Worth Incorporated for participating in this kickoff event. I'd like to start off with our keynote speaker, has been with NuScale since 2016 and helped launch NuScale Robotics in 2018. He's developed partnerships with Universal Robots and Gage manufacturers, helping their customers integrate automated dimensional gauging. Please welcome Stefan Friedrich.
Hi, everyone. I'm Stefan from NuScale Robotics. Excited to be here and kick off the webinar today to discuss how to incrementally automate dimensional gauging. Thanks to the team at MiSTAR Gaging Tool for inviting me to present today. So we're a certified systems integrator for the collaborative robot company, Universal Robots, and we focus on automating part handling and inspection applications. All right, so today I'll show you how industrial robots can be applied to automate inspection processes, whether it's in the metrology lab or automating manual gauging on the production floor. And we'll cover some best practices on how to apply them to higher mix, small batch applications, and go through how to cost justify and create a business case for automation, which is definitely different than a cost justification for just buying inspection tools or different metrology equipment. So automation is becoming more accessible to small and medium-sized manufacturers, letting everyday employees use these new technologies to automate repetitive processes, usually with robots working side by side with people, often without guarding or barriers, which is a new change. And one of the core technologies that's enabled this agile or flexible automation are collaborative robots, which are often called cobots. And today, collaborative robots are the fastest growing industrial robot segment. So collaborative robots do what any industrial robot does. They automate repetitive and boring tasks, but they're different in a few key ways. So the first key difference is that the interface is easy to use and takes more of an app-based approach to automation. So any new commands that you teach the robot are done right through the tablet that controls the robot, which is called the Teach Pendant. It's about the size of an iPad. And I actually think Apple is a good comparison here. So Universal Robots has a platform that lets third-party companies like NuScale Robotics develop hardware and software to interface to their robots, which is pretty similar to Apple's App Store. So UR will test and certify these third-party products as a UR Plus product, and then it goes into their UR Plus App Store. And there's hundreds of different UR Plus certified tools, grippers, welding kits, sanding and polishing products, deburring tools, and of course, quality control technologies that we'll be talking about today. And with these powerful third-party apps and UR's easy-to-use interface, most people can have the robot completing simple tasks with just 20 minutes of hands-on time. And a robot fundamentals training course only takes 2 days. And that's really all most people need to learn how to teach the robot new processes. The robot interface has been designed to be usable by everyday employees. And you really don't need to be an engineer or programmer to use these types of robots successfully. So here's just a basic example of a robot working side by side with people. This is completing a food packaging process. And you'll notice that the robots have no guarding and operate well within reach of the worker. And that's really the second key difference with collaborative robots. They're force and speed limited, so they are typically able to operate around people without guarding after a safety assessment. So cobots support higher mix applications because you don't need to dedicate the robot to one task and one task only all day long. So in general, agile automation targets total volumes, total part volumes in the tens of thousands per month. And this really allows manufacturers to automate at roughly the same speed as a person, take up about the same amount of space that a person needs to perform the task, while improving the repeatability of the process and gaining all the other advantages that you'd normally get from automating a process. So automating something like inspection will free operators or inspectors to do more productive tasks that are better suited for people than a robot, while working side by side with the robot. So with agile automation, robots can be deployed by your in-house team and take up much less time and money to implement if you follow the appropriate steps of incrementally automating a production process. And using this method, you can typically deploy a project in 3 months or less, rather than the normal schedule of 12 months or more. So not having to go all in at once has really made automation more accessible for smaller manufacturers and allows for that lower total investment that helps you get a faster payback for each cell. And I have some costs, general ballpark costs listed there. So we're seeing many manufacturers, especially small businesses, being forced into either considering automation for the first time, or they've had to accelerate their plans to automate production because they just can't keep up with current production levels with existing processes and equipment. And that often creates a quality bottleneck, or they just can't find enough people to produce and inspect the parts that they make due to the labor crisis in manufacturing. And historically, since there haven't been great ways for smaller firms to keep up with the large investments that bigger companies have made in automation, it's made it hard for them to scale their business and be more productive in a way that they can compete with those larger manufacturers. But these new automation technologies are starting to help smaller businesses fill that gap and keep up by reducing barriers to entry and addressing higher mix, low volume production. So we found that quality applications have generally lagged behind other more production-focused robotics applications. Things like machine tending, packaging, welding, and finishing applications tend to get a lot of the love in the manufacturing space, and it's really because they're more production-focused and focused on getting parts out the door. But we're starting to see a more widespread demand for robots in quality departments, and it's mostly due to the growing labor challenge, forcing them to automate. So, the question comes up, where do you start? So the first thing to look for when deploying a robot for a QC application is really where your team spends the most time on manual processes. And that's a general rule of thumb for any automation application. We find that collaborative robot systems that can fill in the hours of one full-time equivalent, 40 hours per week, roughly, gives people an acceptable payback and return on investment that can justify that use of the robot. But, if you're running, especially if you're running 2 shifts, 80 hours or more is ideal, and obviously will generate an even faster payback and ROI. So that's a really good target if you're running 2 shifts per day in your production facility. So I'm going to play a video here. Just load up in a second. So we find that, the best candidates for automation aren't the hardest possible QC processes, but they're things that are simple and time consuming. So, depending on the complexity, it may be worth automating if you just spend 5 hours per week on a particular, sorry, video's not loading up. If you spend, 5 hours per week or more on a particular inspection task. So if you have just 8 types of parts to be inspected, each at 5 hours per week, that's one full-time equivalent employee at 40 hours per week. And, depending on the application and setup, changeover with a collaborative robot from one task to another may only take a few minutes with minimal changes needed. So this video here, we're just showing NewScale's QSpan workstation as an example. So this uses a collaborative robot. We have it equipped with robotic calipers that also function as grippers. So the robotic caliper can measure parts with an accuracy of about plus or minus 5 microns, or about plus or minus 2/10. And it's about 2 times better than most digital calipers, with a micrometer being slightly more accurate. So it lets you do, basic material handling of picking and placing parts, but also lets you measure the dimensions of the part when you grip it, allowing you to automate part handling, dimensional gauging, and data logging with one tool. So the type of tasks that we'll be showing on screen in a second is the basic concept I've been talking about. So you'll see it as the system rolls in the video here. We're automating gauging at roughly the same speed as a person, taking up the same amount of space a person needs to manually inspect parts at a bench, while improving the measurement repeatability and data collection. So this frees that operator to, or machinist or inspector to do, more productive tasks that are really better suited for a person than a robot and are more complex. So, calipers, of course, are not the only tools for gauging parts. So in this example, we've got a gripper caliper picking up the part from a known location at the end of a conveyor. We load it on a bore gauge to measure the ID, bring it under a drop gauge to measure the height, and then the robotic caliper measures the outside diameter. So all 3 gauges we have tied into the universal robot with an easy-to-use interface to teach the system new inspection routines and record all the measurement data to a separate PC. So just as the video showed, we really break down automated gauging into 3 steps: pick, measure, place. So we pick parts from a known location, we measure the features with a specified gauge and record all that measurement data. And then we place the parts into a pass-fail location. You can also sort parts based on size. We're working on an application right now where we have to sort parts in a very small, micron range separation into over 50 different size categories. So just kind of an alternative way if you don't want to just do simple pass-fail. So when we think about ideal QC tasks to get started with, it's really the same as any automation project. We want to focus on those simple, time-consuming tasks. So approaching automation one step at a time is really important, especially if you're just getting started. I really love this summary from Joe Campbell about incremental automation. So he says, if you have a 10-step manufacturing process, you don't have to automate all 10 steps to be successful. Identify one process step worthy of automation, implement it, and start generating the ROI very quickly. So this approach helps you divide the big goal, which may be lights out production, into smaller, more manageable projects and expenses, and really reduces the risk of the project, reduces schedule and scope creep, and it gives you a bunch of small successes that your team can work off of and build off project after project, while giving you that positive return and payback on those smaller investments as you work through them. So another good benchmark I heard from Robotique is ask whether or not you can complete the task wearing a mitten, just 2 points of contact. So it's a really good way to differentiate more easily automatable tasks from something that's more challenging and better suited for the dexterity of a person's hand. Another really important tip from our experience is as the customer, you need to have a robot champion at your organization that's trained on how to use the robot. Take ownership of those projects internally and relay requirements to vendors, provide internal troubleshooting support, and help your team stay on schedule and identify future automation projects. Selecting the appropriate gauge is also important, and we recommend you first try automating with your existing gauging methods. So for example, if you use a manual digital caliper today, use a robotic caliper to make the same measurement. Or if you're using a bore gauge, try using the bore gauge. When you do this, it really expedites the validation and correlation studies that you're going to have to do, and completely changing the methodologies for part measurement will extend the project and development time. And understanding the part features you're measuring is important. We need to understand that we can achieve a sufficient gauge R&R, generally, with the goal of less than 10%. So we'll go into some video application examples here. The first application I'm going to show here is from Orchid Orthopedics, and it was a deployment that we did for them. So this customer decided to automate the inspection of drills. They make surgical drills. So the parts start as raw bar stock and then are cut down to size, adding features of diameters and couplers that they need to inspect. So we're picking drills from the pallet one at a time. We measure critical features with a precision pneumatic drop gauge. And then the parts are sorted into pass-fail bins. And then the data is exported into a computer in a basic ASCII format for use in their final inspection forms. So their goal was to replace the repetitive measurements that their operators were doing manually with micrometers. And a critical requirement was to remove that operator to operator variability that they were seeing from inspectors using those manual gauges and hand tools. The robot effectively acts as a single operator, so that was pretty easy to achieve. And Orchid was able to deploy this system for a family of part numbers to support higher mix, lower volume inspection. So using the cobot, they're able to have their operators trained on the system and repurpose and reprogram the system for a bunch of different part numbers. So using similar fixturing, similar part trays, and programming templates to speed up that part-to-part programming really helped. And once a program's validated for use in production, the operator just simply needs to come over, load a tray, hit play on the program, and then they can walk away and go do something else. So, non-contact gauging methods have a lot of benefits, including speed, accuracy, and digital connectivity. It's a fast-growing segment, but usually still requires staff to load and unload these systems, which is labor that you have to factor in as overhead in the operation. So they can be a little bit more complex to automate depending on the technology and application. Video on the left shows something I would consider a little more complex with camera mounted on the end of a robot arm that's going in to check electrical connectors on this assembly, make sure they're locked in position. Video on the top right shows a drill being loaded and unloaded from a laser micrometer to do a basic OD measurement. And the final video on the bottom right shows how a cobot can automate air gauge measurements. And generally these air gauges require loading and unloading with a pretty tight clearance. So just showing how an older type of technology can be automated and digitally connected. So these are some hybrid applications that I'm showing now. Show contact and non-contact techniques. Top left video, we have a cobot picking a part from a tray. It loads it on a bore gauge that's seated within a laser micrometer, so they can do the inside diameter and outside diameter in one shot. And then the bottom right video shows CMM machine tending. We're finding a lot of overuse and overcommitment to CMMs that a lot of the time aren't exactly necessary, but they have the tool in the shop and they want to use it because it's available and very high accuracy. But for repetitive measurements, there's a big opportunity cost for dedicating a lot of stuff to your CMM unnecessarily. As one example, we had a CMM programmer that said their lab had over a one and a half month long backlog on their CMM, which is just totally unacceptable. This is another application showing some of the more, kind of less tangible benefits of automation. They use a robotic caliper, verify that a part's produced in tolerance, so their machinist doesn't have to. So if the part drifts outside the acceptable tolerance window, the process stops, and a machinist can come over and service the lathe, adjusting an offset or replacing a cutting tool. And that can significantly cut down on scrap and rework rates and give you more reliable data to let you do preventative maintenance. And doing this sort of inspection is really critical if your goal is to automate and have fully lights out production that continuously produces good parts, and tend to the QC functions of the machine. If you want to get much more complex with it, you can also get to fully lights out production by feeding the inspection data back to your CNC machine and setting automatic offsets, which is an interesting new feature. Companies like Karen Engineering have some good software packages for that. Payback and return on investment are definitely important metrics for any capital purchase. Recommend heading over to this link at automate.org if you're interested in doing some sample calculations for any any applications you're targeting. Usually ROI and payback are really the number one motivators for an automation project. It's an important note here, even though we're talking about labor savings, and it's really the biggest motivator for any of these CapEx projects. We have not put anyone out of a job with our robot, any of our robots that we've deployed. So I know that's kind of a scary thing for some people that are not used to deploying automation, but those labor savings are beneficial to the business, and they're often being applied to places where you don't have enough people anyway. Here's some of the benefits kind of beyond a simple ROI calculation. They're better gauge R&R, better process control, better yields, more engaged production team because they're doing less repetitive and boring things. These are much, they're nice, but they're much harder to quantify. Especially when you're thinking about an ROI analysis, but nonetheless, they're definitely worth considering as you evaluate an application. So just to wrap up, a couple key takeaways. As you tackle automation, think about approaching it incrementally to start. You don't have to go all in at once. There are ways to manage that, in smaller chunks. And companies like us or other automation providers can certainly help advise you on the best way to do that. Automation is becoming more accessible, and I encourage everyone to give collaborative robots a try. There's a bunch of different ways to get your hands on a robot. So there's a virtual simulator that Universal Robots offers called the UR Academy that can give you a good feel for the interface and show you how easy it is to use. So I'd encourage you to send machinists or inspectors to go look at those things and try it out themselves. And there's plenty of regional training centers throughout the country that can also give you direct hands-on time with the robot. All right. Thank you.
Thanks, Stefan. Good stuff. Yeah, great technology. To answer the questions real quick, the webinar is being recorded, so you will have access to that. So that was a question on the chat. Our next presenter has 10 years of experience with Marposs Corporation in engineering and manufacturing, and he manages the non-contact products, including laser mics and optical equipment. Please welcome Eduardo Bolivar.
Hello, good morning. My name is Eduardo Bolivar. I've been in Marposs for 10 years. I'm a product specialist for non-contact products. We're going to talk a little bit about the handy wire scanner and also about the Marposs in general, what we are, and the IROL company, that is the laser micrometer company. So Marposs, the headquarters of Marposs is in Bologna, Italy. It's a big plant. There are 3 buildings, actually. The head office in United States is here in Auburn Hills. Marposs, it's a worldwide company and is present in 34 countries. It has a 80 office around the world. When Marposs normally exports 95% of the product from Italy. There are 3,700 people around the world, and in the last 22 years, Marposs acquired 26 companies. What is 26 companies are these? These are companies for leak test, companies for laser micrometers, companies for confocal technology, different companies that help to fill a gap that Marposs doesn't cover at the beginning. Now we cover a lot of gaps that we normally don't cover before. Marposs, the 8% of the revenue always is invested in a new R&D, new developments. And which markets Marposs are is in automotive, aerospace, cooling, EV. Now the EV is coming very strong. The IT, the aeolic, medical stuffs, and glass market. Now let's talk a little bit about ROL. ROL is one of those 26 companies that joined Marposs in 5 years ago. ROL is dedicated for a laser micrometer technology, or for LED. Some of those are LED, but it's for non-contact diameter. This company is been in Marposs. It's been on the market for 42 years. It was founded in 1978, but is in the market selling the same unit for 42 years. What that means? That means the laser is very accurate. It doesn't have any problems with accuracy, any problems with repeatability. It's been proved in a different environment. Why? Because it's always the same laser. It's always the same technology, but it's been renovated with the time. What this can say, okay, how you know it's always the same? Also, you are still old? No. Marposs or RL is been involved from 1980 to now, and now the gauge is the same gauge but in different applications, as we can see here in the pictures. Here we have a grinding application, and then here we have a bench application, and here we have a tubing application or wire application. So, but always is the same technology in the lasers. We have a dual axis laser, or we have a single axis laser. Where we are and which markets we are more present? We are more present in the mechanical industry, wire and cable industry, plastic industry, and the biomedical industry. Talking about wire, the wire in the wire industry is huge, but where we are more focused is in the drone wire industry. This kind of technology, it can be difficult to measure. Why? Because in this kind of environment, you have a harsh environment, and if you have something like this, a dusty environment, the cameras can be, or the lenses can be always dirt, and always is going to be a problem because you don't have a good repeatability, because you don't have a good accuracy, because you will have a dirty problem all the time. So what Marposs invent is, here we have a cleaning device. It's a patented cleaning device to measure or to clean the wire before it goes into the laser. And then this one is an automatic, or is a blowing station that is always blowing, always cleaning the lenses. So this patent allows to the gauge to always work and work really good in this kind of environment. Then the other one you see here, this is something to get the part or the tubing. This is a transparent tubing that is passing through the gauge. This allows to be always in the middle, but it doesn't matter if we have a vibration. If we have a vibration, doesn't matter, because this laser has, in all the measuring field, we have plus minus 0.5 microns, the difference. So it doesn't matter if the cable or the part or the tubing is exactly in the middle, or is on the top, or is in the bottom. If it's doing this, it doesn't affect, because we have the linearity that we have on the gauge is very good. Now let's talk a little bit about the handy wire scanner. What is the handy wire scanner? It's an innovative handheld optical instrument for measuring non-contact diameters in moving wires, like is shown in the picture. This is coming to fill a gap in the measurement that it was before. For example, in the first, I mean, right now, how the people is measuring is taking the spool and take one side of the spool and then measure with a micrometer. Or what it was already is the online measurement. It's like I was talking about. After the drawing, the draw operation, then we have the gauge, we have the cleaning device, and measuring online. But we can measure while the wire is running. We can measure with the handy wire scanner, and we can avoid any issues that at the end we have the whole spool with a bad diameter. Why? Because we cannot measure in between. Okay, so we can go there, check, okay, it's good. Go to the other spool, okay, it's good, right? Then I will show you a video about how is this artifact working on the shop floor. Okay, here we can see the video, and these are the rails, let's say the guide wires that we can align the wire, and it's still vibrating a little bit, and it doesn't affect the measurement. As you can see, you go there, you check it, it's moving, and then make the calculation and take the measure. Go to the spool. In each spool, you can go there and check. What they are doing besides the micrometer is how they are measuring is normally they cut a feet of the wire, putting on the scale, and then the weight times the scale, times what the scale is doing, so they can calculate the diameter with the feet and with the weight. Now this handy wire is coming to help. You can see, can measure transparent products or can measure a non-transparent product. So you can ask and say, okay, but how you will be sure the wire is not going to be like this or like this, right? With an inclination. So ROL has a patented system to compensate that misalignment. So it developed an LED and CCD technology. How this works, it has two crossed linear sensor to automatically compensate the positioning errors. So if you have something like that, so okay, it's not going to measure, right? It's not going to be within the measuring field. But if you have a misalignment within the measuring field, the compensate for that misalignment is going to be done. Okay, what about the performance? We can do what we can do on with this unit and talking about capability studies. This has a measuring field of 10 millimeters, but can measure from 0.1 up to 6 millimeters. If we have the rollers, the guide rollers, like we saw in the video, it can measure 8 millimeters up to 8 millimeters because we know exactly the wire is going to be always in the middle. The repetibility is 1 micron. The accuracy is 2 microns. We normally say plus minus 1 micron. That is totally 2 microns. What is the battery life? The battery life working normally with no Wi-Fi is 4 hours. The battery life is with Wi-Fi is 3 hours. Then after that time, you go there, just connect the unit to your computer or connect directly to a plug, and then charge it, and you're ready to use it again. The weight is not even a kilogram. You can have it, you can put it in your back, in your bag, in your pocket, or you can use some other device to hold the gauge. How you can collect the data? The data can be collected directly through the cable or can be collected in through Wi-Fi in real time. Okay. This, let's say, is a holder, but this holder is not only a holder. It has also here a tag, and this tag can be read by the gauge. The gauge can read the tag, and then you can download the information, and you can tell them, you know what, I'm in this line. In this line, you know, it has this tag. So, okay, go there. The line number 1 is this measurement at this time. So go to the line number 2, and you will have another holder with a different tag. And you're going to say this is number 2, number 3, number 4. And you can measure, or you can read the information in line with this gauge, separating by the tag. So you can segregate every line with these different tags. What accessories do we have? So we have the holder. We have another tag that it can be used always when you go to a different place. This is a hand protector. This is a wire, a guide wire. This is another holder with a tag. And this is use the plug to connect to the computer or to connect to the outlet. So, any questions, any comments, please let me know. My name is Eduardo Bolivar, and thank you.
Thanks, Eduardo. Thank you. It's great technology. I've demoed that gun a couple times, and it's worked fantastic. So, yeah, the handouts, as stated in the chat room, are available. So, with any information, you can click on that and get that. Move on to our next presenter. Our next presenter has been a CMM sales engineer for over 20 years in metrology experience. He manages the sales and support of Mitutoyo CMM product line in the Southeast. And please welcome George Gosnell.
Thank you, Blaine. Welcome, everyone, to the Smart Technology Time is Money webinar. As Blaine said, my name is George Gosnell of Mitutoyo America. I am the product manager for the CMM product line in the Southeastern United States. Today, we're going to talk about the MiSTAR 555 shop floor coordinate measuring machine. But I wanted to start this off as Mitutoyo is not just mics and calipers. We have a full line of CMMs. We just happen to have an exact line that we have made for shop floor situations and dirtier automation environments. So I have an infographic here that kind of shows a lot of the ways where our shop floor series of CMMs and our MeasureLink SPC data collection software can fit in amongst a factory in some forms of automation. And I'm going to play a video here.
Mitutoyo is revolutionizing precision measurement on the shop floor, helping manufacturers to save time, reduce scrap, and save money. Time is money, and Mitutoyo Metrology Solutions save both by offering a complete range of inline and nearline coordinate measuring machines, innovative software, and custom metrology solutions. Mitutoyo CMMs, including the MiSTAR 555, Mach Kogami, the Mach 3A, and the Mach V, deliver optimal inline measurement performance, flexibility, versatility, and high-speed precision measurements on shop floors of every size. This suite of CMMs offer lab measurement accuracy on the shop floor for faster, more efficient quality control around the clock with minimal maintenance. Able to load inline manually or robotically, Mitutoyo CMMs increase part measurement throughput without sacrificing accuracy while reducing the time spent traveling to and from the CMM and manufacturing machines. Mitutoyo's MiCat Planner CMM software enables one-click automatic measurement programs generated from 3D CAD models and product and manufacturing information to increase measurement throughput. MiCat Planner can reduce programming time by up to 95%, which helps keep your production line running while ensuring precise part measurements and quality control. The Mitutoyo M Cosmos CMM software provide 3D CAD model programming, scanning, gear measurement, and airfoil measurement capabilities to speed up development and product processes. M Cosmos allows for integration among a whole series of applications, improving CMM efficiency and delivering greater quality control productivity. The software allows users to tailor their measuring software to include only the specific modules needed to meet requirements, making the measurement process much faster. Mitutoyo MeasureLink SBC software not only speeds up inline part quality assurance, but it serves as a great tool for reducing scrap to keep money in the bank and not on the shop floor. MeasureLink collects and analyzes measurement data in real time and alerts operators of trends, cycles, and nonconformance as soon as they occur, so you can stop the manufacturing process sooner to adjust tooling, reprogram the part, or any other correction that needs to take place. The software's user interface allows a user nearly infinite ways to view information specific to a process from any connected device, helping to keep manufacturing within your chosen tolerances in real time. Let's look at Mitutoyo's inline CMMs with more detail. The MiSTAR 555 CNC CMM offers our complete suite of best-in-class shop floor measurement solutions, delivering fast, accurate inline measurements for a full range of workpiece applications. MiSTAR provides unprecedented versatility and the toughest shop floor operating condition capabilities with best-in-class speed and acceleration. Get the most accurate measurements regardless of dust, oil, and coolants with guaranteed accuracy for the widest temperature range of 50 to 104 degrees Fahrenheit on a shop floor CMM. An easy loading design with 3 open sides saves inspection time by allowing robotic loading and unloading as well as effortless walk-up inspection both inline and near line. And with Mitutoyo's smart measuring system, the MiSTAR 555 offers real-time, remote monitoring capabilities to perform quality control from anywhere with a connected device, an absolute for today's smart factory needs. The extremely compact Kogami automated CMM is ideal for single-feature inspection in automated cells or as a standalone solution. Its 3-axis CNC measuring head, high-speed drive, and flexible design make precision measurement more efficient for small components. The lightweight Kogami delivers CMM capabilities with maximum space flexibility. Install the Kogami on your production line, near line, or directly onto a rigid frame machine tool. This allows for high-speed measurement and quicker feedback and compensation in traditional and smart factory manufacturing processes. The Mach 3A CNC coordinate measuring system is the world's fastest horizontal axis CMM, providing exceptional inline near-line accuracy assurance along its extended Y-axis, even for large machined components. Its easy-to-use touchscreen interface and all-in-one construction streamline and enhance each measurement. The Mach 3A CMM delivers increased drive speed, acceleration, and measurement speed to achieve higher throughput in a smaller footprint while maintaining highly accurate results. Its all-in-one, space-saving design, along with excellent dust resistance and temperature compensation, makes this CMM ideal for inline operations where a reduction in measurement time is required. The high-throughput Mach V CNC CMM uses a flexible measurement system to achieve a drive speed of 866 millimeters per second, making it the fastest inline vertical axis CNC CMM on the market. The Mach V CMM machine delivers rapid, highly accurate measurements of machined components directly within or near your production line. Its barycentric drive system provides high speed and maximum accuracy at lower costs and is engineered for 24-hour operation with protection against harsh environments. High-speed linear guides used in place of compressed air means less maintenance problems occurring. The Mach V's space-saving design, high acceleration, and high-speed probe movement make shop floor quality assurance fast, simple, and reliable. From detecting dimensional defects in part blanks to inspecting the final part with incredible accuracy, you can trust the end-to-end shop floor measurement solutions from Mitutoyo.
Okay, so that took us through all of the Mach series, but I'm going to drill down a little bit further into the MiSTAR and show a few extended slides. And as Blaine has pointed out, under the handout section, there is a handout on the MiSTAR. There's other information available for the other things if you're interested, and just contact Master Gage Tool or Mitutoyo. We can be happy to meet with you and talk about that. So the first thing on the design and accuracy, as you heard her say, we have the largest operating temperature swing from 50 to 104 degrees and still maintaining about 3.8 microns on a linear scale accuracy. We move on to talk about the simple compact footprint of the size of the machine. It really doesn't have a compressed airline fitting. It really just runs off of a standard 120 volt, which means it could be moved around from project to project. It means it could also be reprogrammed in the place of hard gauging. You could move something like this in place and use it for small periods of time. There are different types of probe heads available. There's a fully articulating probe head, a fixed head. We can do contact scanning, and we can do touch probe measurements. The integrated probe rack that's built into the machine actually does not take up the usable measuring volume of the 500. There's actually another 70 millimeters in X that lets the probe rack not take up your 500 millimeters in measuring X. You can see the computer and the controller are all mounted inside the one-piece unit, and the interface comes with a touchscreen monitor, and we can hook it up with our quick launcher software, which could be pictures or barcodes or any kind of instructional views for an operator to walk up to and interact with. It runs the same remote manager that the software runs if it were to be run by a robot. We're just using a graphical interface for operators. Like she covered over, the open legs on 3 sides. The computer monitor can be mounted on any of the 4 corners of the machine, or on 3 of the 4 corners of the machine. The cantilever design lets you put the robot approaching from the side, from the back. You do not have to wait for the bridge to be necessarily all the way back in home position. Temperature compensation on each axis. There is also a workpiece temperature sensors, and there's also a ambient air temperature sensor and moisture sensor to constantly monitor the environment of the part and the machine as a whole. And you can even put in different coefficients of expansion if you're measuring materials like aluminum in a hot environment. You would want to allow for that. The scale technology that allowed the shop floor CMMs to exist, Mitutoyo has made a great step forward in the absolute scale technology that is on this series of machines. It has actually moved its way into our regular line of CMMs because they didn't lose accuracy, but we gained some ability to see through some dust and debris and clutter that used to give us a huge problem for high accuracy glass scales in a shop floor environment. Here are some of the specifications on the measuring range, the accuracies that can be achieved in the different temperature volumes, the resolution of the scales, and things like that, and the linear bearings with no compressed air. A little bit about the MeasureLink software. So MeasureLink that she was talking about in the video is a SPC data dashboard that everything that Mitutoyo makes and anything else that someone has with the data output or the ability to put out a comma-separated variable file or a text file, we can read those measurement data in, and we can graphically portray them and calculate your CPK, your process capability. So like in a normal operation, let's say you had a roundness machine and you're measuring parts and one at a time, and you're sending the raw data over to MeasureLink, and it will track every time you make part number ABC and you did the 10 millimeter bore dimension on the inside. This is the roundness results, and it will chart them for long-term data storage. Another thing you could do is you could have a lot of things in your office or in your manufacturing floor using MeasureLink, and you could be passing from MeasureLink through a QIF format to an ERP cloud that other things could take that actionable data and do things with it. Sometimes in the other cases, there are even machine tools that can take the QIF data or can take direct MeasureLink data, depending on the type of the controller and what type of machine tool you're using. And the machine tool can make actionable adjustments based off of the part inspection raw data from the CMM. These are all fixtures of how we tie together to make a smart measuring system, the SMS technology. We use the statistical data control where MeasureLink ties everything together, and we use the operation status of the status monitor. The new controller in the MiSTAR CMM allows for easy integration into robots, easy integration into a shop monitoring system, some kind of scoreboard, or plant lifecycle maintenance system. So it is ready to talk to and give more information than simply pass or fail. It will give information as to how long it's been running, what is the internal heats in some of the controllers. A lot of good information is there for predictive analytics. So some of the biggest deliverables: the broadest temperature range, the space-saving design, the wide selection of probes. We have a 32% higher acceleration than the competition, 15% higher drive speeds. We have real-time temperature compensation, each axis of part sensors. We're fully enclosed controllers, full bellows, the new scales with 45% more detectable area, 2 types of joysticks, ergonomic design, and the quick launcher software, and a palletized part loading system. So those are some of the key points that make the MiSTAR 555 stand out. And then we do have a special solutions group that does help in integration projects, even down to simple barcode scanners or RFID tags. And these are just a couple of pictures of some examples of that. And with that, I'll turn it back over to you, Blaine.
Thanks, George. Great, fast and accurate technology for the shop floor. Good stuff. Our next presenter has over 35 years precision measurement and industrial sales experience. He's the Southeast Regional Sales Manager for Renishaw, specializing in modular fixturing and fixture plates. Please welcome Doug Emory.
Hello and good morning. Welcome to the Smart Technology webinar. Time is money. And thanks to Master Gage and Tool for inviting me to participate. My discussion today is going to be focused on saving time and money via modular fixturing. And what I'll go through is some applications, the purpose of the fixturing, some examples, and the payback, the benefits from the various fixture products. A little background on Renishaw. Most people in the audience, I'm sure, have heard and seen the Renishaw name. It was founded in 1973 by David McMurtry and John Deere. Different John Deere than the guy that came up with the green tractors. And the product that launched Renishaw was the invention of the 3D touch probe. And the application was actually for the famous Concorde high-speed aircraft. And that invention revolutionized the 3D measurement industry and jump-started coordinate measuring machines. Currently, Renishaw is based in the UK, has 81 locations in 36 countries. My particular product expertise is in the fixturing, but as you know, Renishaw also manufactures probes, probe heads, modules, and encoders, and a number of other products. Getting a little bit into applications, the primary applications that we see with modular fixturing or CMM, they make up the bulk of our business in the fixture group. And for example, we've manufactured many plates for the Mitutoyo MiSTAR CMM that George just highlighted in his presentation. We also manufacture and offer products for vision systems, for articulating arms, and other applications, for example, surface measurement and scanning applications. The primary function of the fixturing is in most fixturing apps, most measurement applications, you have the need to position, secure, elevate, or orient the part so that it can be measured properly. And that's what our modular fixtures do. The base typically is going to be a grid plate. For CMMs, it's typically an aluminum grid plate with a series of holes, threaded holes, that the fixture components can be applied to, and again, to elevate, secure, position, and orient the parts. Here's a couple of examples of parts being fixtured for a CMM application. Some of the products that we offer are the aluminum base plates. We also have a unique system called the quick load rail system. The quick load rail is a steel rail that can be mounted on a CMM in minutes. There are standard plates available in 1/4 and metric sizes that dock to the rail via a locating notch and some magnets. And so you can, in minutes, set up a grid pattern for your modular fixturing on any CMM, regardless of size. And you can also dock the rails in tandem to get more surface area if you have a larger machine. The applications for vision are slightly different in that we typically will use an clear acrylic plate with a grid pattern of threaded holes. The acrylic plates allow the bottom lighting, which is typically used on vision systems, to come through the plate, and that way you can get the profile measurements as well as the surface illuminated components. Nowadays, many of the vision systems also incorporate touch probes, so you have both types of measurement, touch and camera. On the vision systems, our unique modular system, the quick load corner, is similar to the quick load rail system for CMMs. The quick load corners allow you to dock an acrylic plate into a corner and repeat the location of your fixture setups from one application to another. To go along with the base plates, whether they be aluminum or acrylic, we also offer a full line of fixture components, including standoffs in many different thread sizes, diameters, and heights, tension clamps, resting cones, vices, V-holding devices, and pusher clamps. There are numerous gadgets available to get your part in the correct position. And there's a great deal of efficiency in that these are simple to use, they're quick to assemble, and not expensive, off-the-shelf type items. Here's a picture of the quick load rail system. You can see there are some standard size plates that dock to the quick load rail, and you can dock plates to either side of the rail to create the size of the grid that you want to create on your CMM. CMM base plates can be manufactured in any size. In many applications, the end user wants to cover the full measuring range of the machine. So for example, on a Mitutoyo Krista Apex 710 CMM, we will supply a 28-inch by 40-inch plate in 1/4, or similar in M6 or M8 that would cover the entire measuring range. In some cases, there's either tooling or a probe rack on the machine, and we will accommodate that by modifying the size of the plate or locating the plate away from any fixturing or probe racks that are on the machine. As far as the acrylic plates go, there are numerous products available in standard sizes, and we offer these in a multi-hole design, which is mostly threaded holes. We also offer multi-window designs, which incorporate a clear window on the acrylic plate to allow parts that may be sitting flat on the plate to be anchored, yet not interrupted by the threaded holes. And the acrylic plates come in a number of standard sizes, but also can be made in custom sizes. As far as the fixture components go, any component can be purchased individually. We do offer a number of kits for both vision and CMM applications. If you're working with steel parts, we also offer kits that incorporate magnetic components For the vision systems, we have the quick load corner systems. These corners will mount permanently to your machine, and the plates can be docked in and out of the machine. For machines that have devices or some sort of tooling, for example, a rotary chuck mounted on the left side, we also make these for right-handed mount applications. And we do manufacture these for a number of different OEMs, including Mitutoyo. The benefits of using modular fixturing is you can reduce the setup time for inspection applications. And we have many customers that will purchase a plate, set it up, and leave the setup intact for high volume parts. And we have systems like the quick load corners and quick load rails to repeat the location of those setups. Repeatable and accurate results. The fact that you've secured the parts and they're always being held in the same position and orientation produces repeatable and very accurate results. You can also reproduce your fixture setups. There's a number of ways you can do that. One is on the grid plates, they are typically numbered and lettered on the rows of threaded holes. And so you can document your setups. We also offer Fixture Builder software. Fixture Builder software has a library of every component Renishaw fixturing manufactures, and you can, in every thread size, and you can import a CAD model of your part into the Fixture Builder software. You can import the plate you are using, and if it's not a standard size plate, you can construct a plate the size that you intend on using and build your fixture in Fixture Builder, save the setup, and it'll actually document all the components that you've used in that setup. For multiple part setups where you're using CNC programming to do rows and columns of multiple parts, you can also secure those parts and set them up identically in rows and columns when you have the multiple part type setups. And that's it for the fixturing segment. And here's some contact information, and feel free to contact Master Gaging Tool, either the Greenville office or Danville office. I'm locally based in the Southeast, and I have lots of demonstration equipment, and I very often do on-site visits to look at your fixture applications.
Thanks, Doug. Appreciate your time, and great quality product you have.
Thank you, Blaine.
Our last presenter is National Sales Manager for Worth Incorporated, which offers German-engineered precision measuring systems at the highest quality. His career spans several industries, including medical device, aerospace, defense, and education. Please welcome David Caprio.
Thanks, Blaine. Good morning, everybody. So I'm here today to talk about the Worth TomoScope XS line for CT and X-ray machines. So to give you a little bit of background here, Worth was actually produced the first ever TomoScope S back in 2005, and this was the first machine to ever use CT X-ray as a metrology device for 3D GD&T evaluation and analysis. So we literally invented the technology to do this, and we have some of the best technology on the market today. And I'm going to tell you why this is a great tool to save time and really give, for dimensional analysis, give you a great return on investment. So just a little bit of background here in the U.S. We have over 150 machines installed. We are headquartered in Gießen, Germany, which is about an hour north of Frankfurt. And so we've been here in the U.S. here since the early 2000s. And this is the installation base we've accumulated in that time. So we do have a full line of CT X-ray machines that cover a wide range of measuring ranges for different size parts and materials. You'll see here these measuring ranges are in millimeters and in inches for the length and diameter of the measuring range of each system. The line that I'm going to be focused on here, and the machine I'm going to focus on here, is the TomoScope XS Plus. So I mentioned in 2005 we had the TomoScope S. That was the first machine on the market to use CT as a metrology device. 2017 saw the launch of the XS machine, which afforded this technology in a small footprint at high resolution and really fast measuring times. And then 2 years later, in 2019, we launched the TomoScope XS Plus, and that expanded the measuring range of the XS line and gave that same smaller footprint with the fast measuring range, fast scanning times and measurement capabilities. So a couple things to keep in mind when considering, which machine will best fit your application. So we first have the kilovolts for the tube, for the X-ray tube itself. So it ranges from 130 kV in our product line up to 450 kV. And that's going to do more of your, really dense material. So it's all determining on the material of your part and then the size of it. So our XS line operates at the 160, 160, and now 200 kV options for tubes. So you can see here the different materials and the penetration lengths in each material. So you can see here plastic parts, much easier to penetrate. You can put larger plastic parts, smaller metal, steel, ceramic parts, depending on, again, the kV that you have here. And we have some examples of different parts at the different kV levels. So the other component to the CT machine is not only just your kilovolts, but it's going to be on your focal spot size. So the smaller the focal spot size that you produce, the higher the resolution. And the thing with focal spot size is that you're limited by the amount of wattage that you can use to produce that focal spot size. Wattage has tremendous influence and is the factor to determine how fast that your scan is. So there are two major tubes offered in CT X-ray machines. Reflection tubes, so you see here on the left, the energy is generated and then bounced off a tungsten target out through the detector. And then we have transmission tubes, which are penetrated directly through the tungsten target. The transmission tube is a real excellent feature of our machines, and we offer these in anywhere from 160 kV up to 300 kV machines. And what this allows is for really high resolution scans and very fast measurements compared to reflection tubes. So if we take the example of a 10 micron focal spot size that you wanted to produce, that's a pretty high resolution. With a reflection tube, you'd be limited to 10 watts of power. With a transmission tube, you are actually allowed to use up to 50 watts of power, which means that it's 5 times faster than the traditional reflection tubes that we see on the market. So most of our machines have these transmission tubes, so that allows for a much faster scan times. And then even at the higher resolution, most of our competitors top out at 50 watts. We actually can get up to 80 watts for focal spot sizes of 16 microns and up. So again, almost twice as fast as the next leading technology on the market. And you can see here, the comparison scan of a reflection tube and a transmission tube. On the left here, you can see pretty good scan quality here if you want to measure, these holes on the left here. But if you really want to dig in and maybe see that feature that's on the ridge there with the reflection tube, it really struggles to get really high quality resolution, and the transmission tube offers that. So again, the XS Plus is a tremendous machine. This gives some diameters in terms of the diameters and lengths of the parts that we can measure. The MPE of the machine is 4.5 micron, which is also one of the best on the market. We offer it in 200 kV, 160, and 130, and again, max power up to 80 watts. So to give you a little background how CT works, we're taking a bunch of 2D image stacks and we're creating a 3D voxel volume, right? So we're taking a bunch of images and creating this voxel volume. This is basically taking the radiographic images, creating a point cloud from the grayscale values produced in the X-ray, and then we create an STL from there to allow us to go ahead and take our GD&T measurements on the part. So you can start measuring directly on your part. We also have options to do color-coded deviation plots if you want to compare this to a CAD model, or you can do an actual comparison to a nominal of your choosing at different features along the part. So you'll see here, this is our FOV system, which means field of view. That means we're just putting the part in here in front of the detector. You'll notice there's multiple parts in here, and we'll scan it. Doesn't take very long with these plastic parts. Then we have the STL here that we can begin the manufacturing. So really quick, simple, loading the parts in there, really easy fixturing, and putting it right in front of the detector to get to a scan. Here, we'll take those. Okay. So getting back to the presentation here, we have some additional scanning options as well. And so one of these is, you saw in the video there, field of view scanning. We also offer raster tomography, which allows you to do higher magnification scans of your parts. So similar to, a flashlight against the wall, the closer you move your part to the tube source here, in this case, in my example, the flashlight, the larger the projection is on the detector, which allows for higher magnification of your scan and higher resolution. And with raster tomography, you can actually get the part in the full, you can get the full part at high magnification by moving the detector and the tube. And let's see here, we have a second slide here, a second video. So the machine in this video is our XS Plus. Let's see here, we have a tall plastic bottle loaded in the foam fixture. Put it onto the rotary axis here. Here's the rotary axis. This is the detector on the left, the tube on the right. Once the tube is on, we're beginning our scan, and we get our part in position for the resolution that we need. And so you can see right away that this bottle is larger than the field of view. So we're going to take a scan of the top of the part. We're going to drop down the detector and the tube to scan the middle of this part. And then finally, we're going to drop down one final time and take the bottom of this part. And you'll notice the fixture is less dense than the material that we're scanning, so we can see it clearly. And now you might be thinking, oh, this is image stitching. This is great. And it's not. It's actually just recombining the grayscale values of the bottle in the software, so that when we recreate the STL in the software, you're not losing any resolution or any accuracy in the scan itself. And you can now begin your measurements on the part just like you would have if you had it scanned in the field of view. So this allows you to do more high resolution scans and also get larger parts in a single STL for viewing. And then you can just go ahead and do your normal measurements. You can highlight known geometries like circles or cylinders. In this case, you're just selecting the patch, entering your nominal values, doing wall thicknesses, all these things. And the real benefit here is you can cut the part in 2 dimensions, 3 dimensions, however you see fit. So you're not destroying your part. You're able to do internal, external features with tremendous accuracy and speed. So there's the initial programming that you're building in, and then you're basically running it so it can run after that. So to utilize, another benefit of utilizing this raster tomography technology is our workpiece palette changer. So not only can you take a single part and expand the measuring range of larger parts, but you can load multiple small parts into our machine and then use the principle of raster tomography to take individual scans of these parts. And we have one more video. workpiece changer. So you'll see here again, this is our XS Plus machine. You can see here we have the workpiece changer station. These little discs here have magnetic plates on them that are picked up by the rotary axis. And you just drop your fixture on top. Essentially take the scan of your part, put it back, grab your next part. So this really reduces operator load time. You can pictureally put a robot so that they're just entering into parts in a batch and then going through and scanning all your parts. So depending on the size of your part, you can scan as many as 100 or whatever you can fit in the measuring range. You can start to, you can load them up, scan it, run it overnight, and do true lights out evaluation and analysis of your part with the TomoScope XS or XS Plus with the workpiece pallet changer. So this was a real great add that we made to our machines here earlier this year, and we see it as a real game changer, and we're seeing our customers really enjoy having the option to load all these parts in ahead of time and doing some lights out analysis of their parts. So getting back to the presentation, so some of the software features that save a ton of time as well. We have the automatic separation of parts. So you saw in these videos, we had multiple parts fixtured in one spot. The software can separate the STLs quite easily. You can build a measurement program and then loop it for as many parts as you can fit in your measuring range. We also have automatic void detections. This is great for injection molding products. You can do this. You can go through two-dimensionally and view the voxel volume, or you can do this right on the STL and do color-coded deviation plots for the size of your voids to determine which ones are of most interest to you. We also have burr detection, which is a CAD comparison software module. So essentially here you have on the left a part, an STL that has some extra material here, and you can see the CAD here does not have that material. And so overlaying those with a CAD, you can easily highlight where that burr is and how far out of tolerance that the burr is, and highlight that and remove it from your evaluation process if you want to. And then finally, this is a really, really impressive piece of technology, our WinWare TomoSim. So for the first time, our development team has come up with a way to basically virtually mimic a CT, a computed tomography scan of a part without actually using a CT scanner. So basically you type in the part material, the size of the part and general parameters, and you can test what it would, the resulting STL, scan time, the kilovolts needed, the wattage needed. It'll even simulate artifacts. If your part is a little too dense or it has some complicated material in it, it'll show you where you're going to have a problem in the CT scan without taking up machine time away. So you could do this, offline with TomoSim. So this is the first time anybody's been able to do it. So even if you have a part that isn't in existence yet that you've created, as long as you have a CAD model, you could load the part into the software, dial in the material, and simulate the scan. So this is really great information in a way for operators to utilize and test out their ability. You can even do offline programming on parts without taking up machine time, which is obviously extremely valuable. So to sum it up, the TomoScope XS Plus and the entire XS line offers fast scanning and evaluation times, and that's because we have the only micro-focus transmission tube with a monoblock design that's capable of getting to 80 watts. Our workpiece pallet changer offers maximum throughput and even gives you the ability to do lights out operation if necessary to free up your operators to go and do other elements of their job without having to wait to open the door and put in new parts. Offers a small footprint. The XS Plus here, you can see here, just under 60 inches wide, a little over 30 inches deep, and just under 60 inches in height. And it weighs just over 3,000 pounds. So it can go, in virtually any environment. You don't need a special floor or anything like that. And then on top of everything else, our industry-leading software development really sets us apart in the CT X-ray area. With the raster tomography and the TomoSim, we're really setting ourselves apart with our technology. So I appreciate your time to hear a little bit about the CT X-ray. Feel free to reach out to myself or Blaine if you have more questions. And thanks for your time.
Thanks, David. Unique technology that only Worth can offer. I'm telling you, it's really good stuff. So, thank you, everybody, and take some questions real quick. Now, remember, enter your questions in the Q&A chat room, and I can ask the questions to our panel here. David, I got a couple questions for you. What industries does the TomoScope XS line serve best? How many parts can you measure at one time? Is offline programming available? So,
sure. So, so the industries, I would say, medical device is a big one. Dental implants, anybody, plastic injection molding industries, basically anyone that have, smaller parts. And again, but we do have larger measuring ranges, but the XS line in particular, with those high resolution, fast scans, basically, anything under 18 inches, long, I would say, can be scanned quickly and accurately, depending on the material. So those industries lend really well. Dental implants, those industries lend really well. I believe the second part, how many could measure at one time. So I think I mentioned during the presentation, you're really limited to the measuring range of the machine and the material. So assuming you could penetrate the one part, if you can fixture as many of those parts you saw in the video. We had, I think, 5 or 6 little plastic parts that were staggered together. As long as those parts don't touch, you're only limited to the amount, to the measuring range of the machine. So however many parts you can fit in there, and it doesn't add scan time either. So keep that in mind, that if you could do it in a single field of view scan, let's say it takes 5 minutes to scan a single plastic part. If you load 5 of those, well, it still takes 5 minutes to scan all 5. So you just went from 5 minutes per part to 1 minute per part. So that's also an advantage of CT. And then the last one was the offline programming, and absolutely, we do offer offline workstations. And again, the goal of these machines is to have them scan. That's where you're going to find the most return on your investment and save the most time, right? But when that machine's scanning and creating the evaluations and everything, that earns your money. So we do offer offline stations where you can take advantage of the TomoStem, or you could just do some offline programming and analysis as the machine continues to scan your parts, especially using the workpiece pallet changer.
Great. Another real quick one is, does your software have the capability to remove the fixturing from the scan and show only the part?
Yeah, so the STL doesn't show. You'll notice the STL, you can't see the fixturing. So the fixture just has to be less dense than the material that you're scanning, right? So customers use all unique ways. We're seeing a lot of customers use 3D printing now to really come up with new inventive ways to fixture as many parts as possible in the machine. So yes, absolutely. The default for the system will produce an STL with the densest material. So that's why you don't see the fixturing in the scans.
Okay, great. Any other questions anybody has? Give it a couple seconds, but remember the handouts in the chat, and then you can click on that and get any information. And also keep your eye out for future webinars coming from Master Gage and Tool for other products coming up. I do have for Stefan, what type of gauges can you automate and work with? For Stefan,
we can use a lot of different gauges. I mean, generally, if a person's using them and manually loading them today, they can be automated. But certain hand tools like calipers, micrometers that you can't actuate with a robot. Those require alternatives. So, like I showed, the robotic caliper. We've used drop gauges with special fixturing to emulate a micrometer.
Okay.
So,
good.
A lot of different options available.
Good. Eduardo, how accurate is the handy wire scanner?
The accuracy is 2 microns.
2 microns.
Plus minus 1.
Very good. Okay. Great. All right. Well, I don't see any questions, but if you do, feel free to reach out to Master Gage and Tool, your sales rep, or or give us a call at our office at 434-836-4243, and we can get you set up. In the meantime, thank you for everybody for joining us, and keep an eye out for any future webinars, as I said, and check out our website, mastergt.com. And this will be recorded on our this recording will be on our website for any future information. So thank you again, and have a great rest of the week.
Thanks, Blaine.
Thank you. Bye.
See ya.